Hello everybody, my name is Mohammed Jaradat. I'm a master student at Gibbs Technical University at Earthquake Engineering Department. Today I would like to present you the 512 course project, Matrix Methods in Structure Analysis. The project title is using Python Program Analysis and Design of Two-Source Sea Structure System under Seismic Load. My colleagues' names is here attached and under the supervision of Advisor Assistant Professor Ahmed Anil Dindar. The contents of this presentation: the first thing, importing the data. After that, defining the required functions in the project requirements, such as the response spectrum function, finding the stiffness and mass matrices, finding the structure period, make the required calculations of base shear force and its distribution of the structure, applying the boundary conditions and finding the reduced matrix, finding the internal forces and stresses, checking the sections and design if necessary, and finally the conclusions. Here attached our architecture drawing, 2D architecture drawing, and here attached the section, the cross section in the used in our project. The first thing, we just created the Excel file and we put inside it the whole project properties from the node number, frame number, starting node, and other cross-sectional properties. And after that, we just write the code just to import the Excel file. Here we can see. After that, we define a function just to find the response spectrum coefficient according to the Turkish Seismic Code 2018. He just take the period value, for example this value at 1 second. He just calculate the response spectrum coefficient according, of course, the Turkish Seismic Code 2018. Here attach the function that we wrote in Python. Here the range of SS value and S1 value. He just calculate the FS and F1, and after that just calculate the SDS and SD1 values, and after that we calculate the response spectrum coefficient, and we plot the relation between period time T, which is the period of the structure, and the response spectrum coefficient. After that, we define a function just to find the stiffness and mass matrices. For the stiffness matrix, we here attach the function that we use to find the element stiffness matrix. After that, we define another function just to find the transformation matrix for each element, and the object of this transformation matrix is just to transfer the element stiffness matrix from local coordinate to the global coordinates according to the orientation of the member in the global stiffness matrix. So the global stiffness matrix was 18 times 18. It depends on the number of nodes of the structure. In our project was 6, and every node has 3 degrees of freedom, so 6 times 3 is 18 degree of freedoms. After that, because it's two-story building, so the system stiffness matrix according to multi-degree of freedom system and dynamic structures, the stiffness matrix is 2 times 2 and the mass matrix 2 times 2, and after that we will use these matrices just to find the period. Here, just to find the structure period, we use the previous matrices to find the omega square values, which is called the eigenvalues. From the eigenvalues, because it's a two-story, so there is two mode shape. For each mode shape we find the period, and after that we took the maximum value of the period, which is about 0.67 second. Here attach the code that we have written just to find the eigenvalues and the period for each mode shape. For this value of period T at 0.67 second, we calculate the response spectrum coefficient. After we found the response spectral coefficient, there's a modification, there's a reduction for this response spectral coefficient. using the R value of 8 and importance factor of 1.5 because it's a dormitory structure, and D equal to 3 according to the Turkish Seismic Code 2018. Here attach the value of reduced response spectrum. After that we define the function just to find the to calculate the base shear. After finding the base shear, here attach the value of base shear. We divide it by 4 because there is a 4 nodes, and here the nodal force at each node equally as it's needed from the project. Here applying the boundary conditions, here the boundary conditions of the structure, and finding the reduced stiffness matrix and load vector. The reduced stiffness matrix was 12 times 12 and the reduced load vector was 12 times 1. Here attach the code that we use just to get up with the reduced stiffness matrix and the reduced load vector. After that we find the internal forces and stresses. Here the element internal forces for each element, for example for the first element, and here attach the internal forces for each element, the shear force and the axial force and the bending moment force. After that we find the maximum internal forces in each element and also the maximum internal stress at each element. After that we came to the design and redesign process. In this part of the project, the program is take the maximum stress at each element and compare it with the allowable stress. Here is 4S in French. So here if the maximum value of stress in each member is more than the allowable stress, so increase the value of section, increase the value of dimension, section dimensions in each step with 1 millimeter. So in this step it will increase after up to the allowable stress be less than the up to the maximum stress be less than the allowable stress. So after that he will get out from the this loop. So the optimal width after that will be printed. The optimal width is 0.39. So at about 0.4 meter is the sufficient dimension. The previous one was 0.2. So he increased from 0.2 meter up to 0.4 meter. And the corresponding period here attached about 0.55 second for this dimension. So we after that calculate the reduced the response spectrum coefficient, the new response spectrum coefficient corresponding to this value of period. So as a conclusion, to calculate the storage displacement under earthquake loading, modal combination method was used. Since frame is two-story frames, there are two different mode shapes. For each mode case, lateral load at story level and displacement for each were calculated. The displacement of the structure were calculated by using SRSS rule between mode shapes, and after we find the base shear value and the nodal forces, and by applying and calculating the internal forces and stresses, we found that the initial value of A, which is 200 millimeters, is not sufficient. So the program calculated the acceptable one and made the whole modification from the Excel file input up to response spectral curve according to the new values. Here the code that we have written here, he just take the new value of A. For example, when it's 0.2, he increases to 0.21. 0.21, he take this value and put it in the Excel file. He modify the Excel file, and after that he re-import the Excel file and make the whole procedure from defining the response spectra and find the internal forces and then internal stresses, and just to make them the comparison between the allowable stress. As a references of this project, of this presentation and project also, the first thing was a class node, of course, and Python scripts and SAP program, and of course the Turkish seismic design 2018. Thank you for your listening.